So 10.2 is all about factoring trinomials. And what you did on your bell work is you did foiling. So foiling is first, outer, inner, last. So we multiplied x times x and we got x squared. We multiplied x times 7 and we get 7x. 5 times x gave us 5x. And 5 times 7 gave us the 35. What we typically have here is common terms. And so our like terms then can combine. 7 and 5 gives us 12x. So our final answer here is x squared, 12x, and 35. And with something like this, with x squared, the way that we got that was just x and x. So that was easy. 35 was a product of our last two things, 5 and 7. And then what we found is the middle, that was actually the addition of these two, 5 plus 7, right? And so as we move towards factoring, what's going to happen with factoring is you're going to be given a trinomial that looks like this, and I'm going to ask you to give me the two binomials that created it, all right? And that is factoring a polynomial, And so if you look at the first example, the way we're going to solve these when it's just an x squared, when it doesn't have a number in front of that x squared except for 1, the way we're going to factor these is we are going to start by looking at the last term, 6 in this case. And we're going to list all the factors that we know of 6. Now, what I mean by factors is two numbers that multiply together to give me 6. And I'm going to list all of them. 6 is actually kind of easy because there's only 2 sets. All right. Then I'm going to find which of those factors would add up to give me the middle term. All right. And so I am going to look at 6. My options for 6 are 1 times 6. Everybody agrees 1 times 6 equals 6, right? And then 2 times 3. 2 times 3, all right? So then I'm looking for which of those add up to give me 5. Which pair? This pair or this pair adds up to give me 5? The second pair. Now, specifically, is it a positive 5 or a negative 5? Negative 5. So my question then would be, how do I add those two and get negative 5? What must they be in order to add them and get negative 5? Luke? Both negative. So I have to have a negative 2 and a negative 3. Does negative 2 and negative 3 add up to negative 5? Yes. So then we have to make sure, does negative 2 times negative 3 multiply to give us that positive 6? Yes, it does. And so that is how I'm going to factor. I'm going to say, well, my first one is definitely just going to be an x. In these groups, x times x, that's definitely going to give me an x squared. And then I have figured out I need a negative 2 and a negative 3. Negative 2 plus negative 3, add to give me that. Negative 2 times negative 3, multiply to give me that. So the order does not matter because it is multiplication. So if I did this, this will be the same thing. As long as they are both a negative 3 and negative 2, it doesn't matter which order my groups come in, because if I FOIL it, I'm still going to get x squared minus 5x plus 6. And so either of these would work as an answer, and you can check it. How do you think you could check to make sure you factored it correctly? If I want to check it, I could FOIL it, and I should get what I started with. I would recommend you box your answer before you check it, because sometimes I'll have people FOIL it, and they will go down here, and they'll do my foiling, and they'll come to this guy, and then they'll box them. That is not my answer. That was my question, right? And so don't box the answer as you're checking. Make sure you box the actual answer, the factoring, okay? So this looks a lot like the first one, doesn't it? What's the difference between this one and the one we just did? Right, and so I have some changing of my additions and subtractions. So now, question. So this is a positive 5, but this is a negative 6. So if I am multiplying two numbers and getting a negative number, what must be true about those two numbers? If I am multiplying to get a negative, what has to be true? Yes. So the only way to get a negative number at the end here is that one is a positive and one is a negative. So I am going to list my factors again. But now one is positive and one is negative, and I need a positive 5. Which set am I going to use? Chandler. I'm going to use the first set. And how am I going to get a positive 5 using a 1 and a 6? The 1 is negative, the 6 is positive. So then I'm going to check. Does negative 1 plus 6 equal positive 5? Yes. Does negative 1 times 6 equal that negative 6? Yes. That is my correct factoring. So my first one is just going to be that variable for both of these groups. And again, it doesn't matter which way I put it as long as the negative goes with the 1 and the positive goes with the 6. That would be my answer, and I can check it. I'm going to FOIL it. Y times y, that would give me y squared. Y times positive 6, positive 6y. Negative 1 times y, negative 1y. Negative 1 times positive 6, negative 6. If I combine those like terms, y squared plus 5y minus 6. I did it correctly. Here, when I did this, my middle sign was plus. That told me the 6 was plus. It's larger than the 1. So when I see the positive, it automatically tells me I have the same sign. I could do positive times a positive, or negative times a negative would also give me a plus C down here, right? Positive times positive is a positive number. Negative times a negative is also a positive number. So then once I see this as positive, my brain's going to say, okay, they have the same exact sign. My groups will have the same sign. Now I just need to figure out which one it is. So then I'm going to look at this middle one. If the middle one is plus, they're both going to be plus. If the middle one is minus, they're both going to be minus. All right? Then let's look at the other situation. Let's say this last guy is negative. Then I automatically know I'm going to have a plus and a minus. Now I just need to decide which one is plus and which one is minus. So this will help me because if I am adding two numbers with different signs, the answer is going to follow the sign of my bigger absolute value, right? So if we looked over, so here, if I have a negative number, I'm going to look here to decide which one has the plus or the minus because this middle guy will follow the larger. It will always follow the larger because you're subtracting is what you're doing with a plus and a minus. So let's look at some other examples. Factor 72 is what I'm looking for. And so if I list all my factors of 72, what I typically do to list factors is I start with 1. 1 and 72. 2 and 36. Does 3 go into 72? It does, right? 7 plus 2 is 9. So it goes in 24 times. What about 4? Does 4 go into 72? It does. 1 and 8, right? What about 5? Does 5 go into 72? No. It does not. What about 6? Yes, 12. What about 7? No. What about 8? Yeah. 8 and 9. And once you get this, the next one's going to be 9 and 8, and you're just going to go down from there. These are all the pairs that multiply to give you 72. Okay?
So you only have to do 9.
All right, so looking at this, negative 72, what does that automatically tell me about my signs? One will be positive and one will be negative. So I automatically know that I'm going to have a positive and I'm going to have a negative, right? Automatically know that because this has to multiply to get a negative, all right? Now, this tells me the larger one is positive. So now I'm looking for a pair of numbers that are just how many apart? What's the coefficient here? What's the coefficient on this x? A 1. So I'm looking for a pair of numbers that if I subtract, I get 1. Which pair gives me that? Which one is positive and which one is negative? I want a positive 1. 8 is negative and 9 is positive. Negative 8, positive 9. Is that going to work? If I say negative 8 plus a positive 9, what do I get? 1. If I say negative 8 times a positive 9, what do I get? Negative 72. That's what I'm looking for. So I want my 8 to be negative and my 9 to be positive. And I have successfully factored my trinomial. and I can check it. All right. 8. When I check this, I'm going to say x times x times negative 8, 9 times x, and then positive 9 times negative 8. When I simplify, I'm going to get what I started with, which is exactly what I wanted to do. Factors of 6, what are there? There's pairs. What's the pairs that you have? 1 and 6 and 2 and 3. What does this tell me about them? They're both the same sign and they're both specifically positive, right? How do I know they're both positive?
Because the other sign.
This middle guy, right? So here's the problem. They're both positive, so we know that all of these have to be positive. Which pair adds up to 3? None of them. This guy's prime. You cannot factor him. There are no factors of 6 that add up to 3. Doesn't work, all right? No factors of 6 that add up to 3. So this is prime. Just like when I didn't have a common factor to take out in the last section and I said, hey, it's prime, I really can't take anything out except a 1. Same is true here. There are no factors of 6 that add up to 3. They don't exist. It is not factorable, which means it's prime. For this particular one, my greatest common factor is what I want to take out. And I'm going to take out that 2. So I'm going to say, what happens when I do 2 divided by 2?
A2.
I just have my a squared. What about the 64 divided by 2? There we go. And what about this last one? And so now I am looking for factors of 144 that add up to what? Or subtract 2, get 32, all right? And so this is going to be a little bit more difficult, and I will say I probably won't give you numbers quite this large yet, all right? But you can do the same process, which they did it for you in your book. So if you look at the top of page 411, they listed these factors for you. 1 and 144. They did 2 and 72. They did 3 and 48, and they did 4 and 36, all right? I will say a little hint. When you get close to 32, you're probably at the one you want, all right? So you can see if I were to subtract this, we're going to get, they're 143 apart. They're 70 apart. They're 45 apart. How far apart are these? They're 32 apart, right? Does that make sense? So when you get close to that middle number, you're probably getting close to your answer with something like this. I want a negative 32. Which of those needs to be negative then? Remember I said the larger of the two needs to be negative? So my 36 is negative, my 4 is positive. So when I factor this, I am going to have a negative 36. I am going to have a positive 4, but I actually still have that 2 out there. So anytime you are factoring and you have to take out a common factor first, that common factor will be part of your answer, okay? Because I should be able to multiply my answer and get what I started with. If I left this 2 off and I multiplied these, I would only get this right here. I would not get this, okay? And my goal when checking is to get what they gave me. So that common factor is part of your answer. And if you take a common factor out, then when you give me the factors, you need to give me the parentheses, but you also need to list this common factor in front. And then you're going to factor the inside the same way. This one's a little bit smaller. So you're going to look at all of your numbers and you're going to find out what is in common between all 3 of them. Take it out and then do your factoring on the inside just like we've been doing. So you'll notice this one has an x squared, and this one also has a y squared, all right? Does it have a common factor across all three of them? No. I have a 1, an 11, and a 24. Then I have an x squared, I have xy, and I have y squared. I do not have a common factor between all three of them. How this works, I need to get an x squared at the beginning. So if I'm foiling and I need an x squared at the beginning, I'm going to have an x times an x. Okay? At the end, I need a y squared. So I'm going to have a y and a y. Everything else is done exactly like the other ones. I'm going to look at just the numbers. 24. I need factors of 24. Are they both positive, both negative, or one of each? They're both positive because they're the same and this is positive. So I need factors of 24 that add up to 11, all right? I'm going to list them. 1 and 24, 2 and 12, 3 and 8. Have I gotten it yet? Yeah. Which of those add up to 11? The 8 and the 3. Positive 3 and positive 8. They add to give me 11, right? They multiply to give me 24. And so that's what's going to go in here. A positive 3 and a positive 8. So x plus 3y, x plus 8y. So let's see if this is going to work. We're going to check our work. X times x. What is x times x? X squared. X times 8y. What is x times 8y? 8xy. What is 3y times x? 3xy. What is 3y times 8y? 24y squared. Do I have any like terms? Yeah, these are x squared plus 11xy plus 24y squared. So even if you have multi-variables, as long as you can divide them up and say, oh, x squared, that's x and x, y squared, y and y, then just look at the numbers like you would for anything else. Just look at the numbers. All right, let's try one of those.